Hello everyone, welcome back to lesson 2 of Risk Hub Quant Primer. And today in the Mathematical Foundations, the chapter 1 of the lesson 2, we'll be learning about algebraic expressions and functions. What they actually are, what is their use in the field of finance, and how many times are you actually going to see them in the quant finance world, and why they are the actual base that everything builds upon. All the functions, all the average expressions, all the equations, how do they come in play when you're actually talking about real world finance? We'll be talking about returns, risk measures, time value of money, present value, everything, distributions, regressions, hypothesis. You counted your all the equations or the theorems. Everything is based upon the simple identity of algebraic expressions and the functions that are derived from it. Now we'll be talking about what actually algebraic functions or expressions are made up of. What are these functions made up of? What are these equations made up of? How do you solve them? What are we actually gaining at the end? That's the important stuff we'll be talking about today. So let's first talk about what is an algebraic expression and what is it made up of. Algebra. We all studied in 7th or 8th class, or maybe we started in like 6th class. I don't know. But let's say. So algebraic expressions are made up of three things. There is a variable, there is a constant, and there are these operators. Variables, constant, and operators. What are these variable terms? Any kind of A, B, C, D alphabet in maths can be a variable. And maths is a variable. Uh, what are we actually talking about? Let's say A, B, C, X, Y, Z, any kind of these that take any value. There is a variable now. They take up any value, and that's why they are called variables. What are constants? Constant are the term that are constant. Like let's say plus 3, minus 7, plus 2, minus 6, 5, 8, plus 5, plus 8, minus 42. Any number that's a constant, that's as it is, that's your constant. Operators, plus, minus, divide, multiply, those are your operators. Examples of these algebraic functions can be, let's say you're taking in anything, rates of returns, you are taking, um, okay, A plus 6B plus 23. This is an algebraic expression. It has a variable. It has this variable. These terms are known as coefficients. This is a constant, and these are the operators. If I put in any value of A and B, I'll get a number. I'll get an answer. That's the solving the algebraic expression. We have these rates formulas. We have present value formulas. We have simple interest formulas. Uh, let's say amount into 1 plus rate raised to power t. Let's put in amount as principal p. This is p, this is 1 plus r raised to power. This is your compound interest formula, basically. Compound interest plus amount formula. And this is the value you get. There are the t and the p are variables. The operator is in multiplied, and the constant is suddenly plus 0. That's it. So these are the algebraic expressions that we'll be talking about, that we'll be learning aage jaake. Then, when we talk about an algebraic expression, what are its terms, coefficients, and variables? So let's say I take up an equation. I take up any sort of, let's say I take up 5x square plus 8x minus 9. That's it. That's all I'm taking. This is an algebraic expression. What are the different terms of it? Everything that is kind of taken separately, all the numbers differentiated by the operators are the terms. So 5x square, 8x, and minus 9 are your terms. What is a coefficient? A coefficient is plus 5, plus 8, and plus 8. These are the coefficients. What are the variables? X is the variable because there is the only one variable. X is the variable. Squaring is just putting up an effect with X. That's it. X is a variable. These things are the coefficients plus 5 and plus 8. These are the terms individually. And the constant, as we have all talked about, a constant क्या होता है? What is a constant? That is as it is. It has no other value. Minus 9 is the constant. This is an algebraic expression, what it is made up of. Now, what is an equation? What is an algebraic equation? So sorry. What is an algebraic equation and what are these expressions? So when I take up, just leave this heading. Okay, let me just insert a new one. New slide, blank. Yeah. So when an expression is written as it is, there is no equality sign. There is nothing equating it to. Let's say there's this equation 8x square plus 2x plus 3 is equal to 0. So then it is an algebraic equation. But when there is no equality symbol, let's just say it is as it is. This is as it is. Then now it becomes just an expression. How do you simplify these equations? How do you simplify these expressions? We have to find answers to these equations. Na, ki x ki value, what is the value of x? What are we actually trying to do? So there are three ways. We have combining the variable, combining the terms. That's one thing you can do. Combining. Then there is factoring, and then there is expanding. Combining, let's say you have a variable x plus 3x plus 2x. What you can do? You can just say it's x plus 3x plus 2x. It's if it's a single x, then it's 1x. Now there is one single term of x, 1x plus 3x plus 2x. It becomes 6x. That's how you simplify it. You just combine the equal terms. Let's say there is one more. Let's say there is x plus 3x plus 2x square plus 4x. Then what do you do now? You have to combine the x terms, which are 3x plus 4, 7x, and x, which is 8x, 8x, and now you do 2x square. You cannot do this. You cannot say ki x plus x square is equal to 2x square. That doesn't make sense because x and x square are different. There is this square thing now. So you say 8x plus 2x square. What are the other things that you can do? You can say 8x plus 2x, then I can do what? Let's take this equation now, factoring me. 8x plus 2x square. What do I take in common? What is the common thing here? It's 8x plus 2x dot x. There is 2, there is 8. What do I take? I take 2x out. What I'm left with? I'm left with 4 plus x. This is factoring. I made factors of this thing, and let's say now it's equal to 0. So either 2x equal to 0 or 4 plus x equal to 0. This is another thing we'll be doing it when we are solving algebraic equations. That's the factors and that's the answers to get algebraic expressions. And then there is this expanding thing. How do you expand it? Let's say there is a variable. We have all heard about this thing. That's the common thing that, hey, I don't remember anything from school, but I remember a plus b whole square is equal to a square plus 2ab plus b square. That's it now. That's what you're going to do. And that's the important stuff in remembering in finance also. Portfolio variance when you will be calculating. It will be calculated using these identities. A plus B, what is the square of A plus B? When you will be making some stuff up, when you will be solving formulas and when you will be solving equations, portfolio volatility, variance, tracking error, standard deviation, standard error, all these terms you will go through. So these algebraic expressions and their equations and their identities really come into play. A plus b square is just a square plus 2ab plus b square. That's expanding in, that's making your life easier. That's it. Oh, we talked about all of this now. We just talked about it. Now the other is equations versus expressions. Talked about it right now. That expression is just, let's say, r square plus 3x plus 1. That's it. That's an expression. There is no equality sign. There is no equation being it. I don't know what the answer is. This is just something. Put up the value of, okay, let's put it x. Put up the value of x in this and I'll get the answer. What is an equation? This is an expression. What is the equation? Equation is basically when I have something equating it to. Let's say I have x square plus 5x plus 6 is equal to 0. Now, what do we mean by it? So, like, this is an equation. This is an equation that can be solved. Uh, yeah, this is an equation that's equating it to 0. How do you solve this equation? So, let's say this is solved by x square plus 2x plus 3x plus 6. I take x common, x plus 2 plus 3 common, x plus 2, and then this I get 0. And then I have two things. I have x plus 3 into x plus 2 is equal to 0. Yeah. Now I have what? I have either x is equal to minus 3 or x is equal to minus 2. That's the answer. Any of those two answers actually support this equation. And okay, no, there are no real answers. And then we get the answer. Okay. And then when you solve it, you either get x is equal to minus 3 or x is equal to minus 2. Put any of these answers in this equation, and this equation will be solved. The answer will be 0. That's how you solve a linear equation. There is another method also that we'll talk about in further lessons. Now, what are functions? Functions are basically a function is mapping one input onto the other. How do we do it? Let's say y is a function of x square, or let's say y is a very easy x square, or y is a linear function of 2x. This is a function. Y is a function of x. How do we solve it now? Let's say 0. This is the y and axis, and this is the x-axis. So for every single, let's say it started. X is 0, y will be 0. X1, y2, x2, y4. x3, y6, x4, y8. It increases linearly. This is a linear function. Y is a function of 2x. Y is a function of x, and that's it. Y is equal to x square. Now, what does that mean? Y is equal to x square means 0, 1, 1, 2, 4, 3, 9, -1, -2, -3. So it comes as this and it goes as this. This is a function. What will be the y of value when x is 3 or when x is 4? There y is a function of x. This is used in when you're calculating price of a bond. Price of a bond is a function of, we'll talk about bonds, what are they? It's in a fixed income instrument, debt instrument. So we'll talk about bonds. We'll talk about why is price of a bond is a function of interest rates. That's yields. That's a function. We'll talk about your present value of the money. That's a function of interest rate, time, and the amount you're putting in, amount you're getting after certain years. These things matter. What's the payment you're getting, how your EMI is calculated, the time value of money, the rate of the bond. The interest rates in the future is a function of the interest rates today and the volatility, the spot rates, the returns on the stock. These are all the functions of something, and that's what functions are. Function is mapping one variable onto the other. Now, what are the types of functions that are used in FRM, any in like quant finance? So we have linear functions and we have non-linear functions. What is linear? What is non-linear? When your line is a line, and what we did, we calculate, we made here a line now. This line, this this is a line. This is a linear function. That's a straight line. When your line is a curve or something else, it's a non-linear function. Your log x is a non-linear function. These are the numbers you will understand in a few videos. Ex is a non-linear function. X cube is a non-linear function. Your anything else is a non-linear function. Okay. When there are powers and orders included, becomes a non-linear function. When they're multiplied or there's simple addition, let's say x plus 6 or x2, x plus 3, this is a linear function. So these kind of functions will be used. Second thing, what do we use? And in a function, there is a concept of range and domain. Do have it in different way, in the opposite way. It's basically domain first and range. What is the domain and what is a range in the name of a function? So the thing is, a function, let's say it's y is equal to log x. X domain is a range of inputs that you can put into the function. Range is the set of outputs that you can receive. The range of outputs that you can receive. Domain is the set of inputs that you can put inside the function. The log x function has its domain greater than 0. X should be greater than 0, otherwise you will get an error. It cannot be less than 0. Log x cannot be less than 0. It has to be greater than 0. X has to be greater than 0. And the range is minus infinity to infinity. That's the range. The range is this output that where what the output can be, and the domain is the input that you can give. X square. Okay. Possibility of an event happening. Probability. It's a concept of probability. Probability of an event happening as a range of 0 to 1. 0, either it's not going to happen at all, or 1, it's certain to happen. There are things in between, but no probability can be less than 0 or greater than 1. If it is, then your model is wrong, your calculations are wrong. Please check them again. But that's the range of the output. Input can be n number of things, can be anything. That's the domain. Okay. So this is where we end our lesson 2, and let's meet you on lesson 3, where we'll talk about a little more things: logarithm, exponentials, more functions, more exponents. What is this? How do they actually come together in finance? Have a great day.